of this problem is to understand how couples work. Let me consider a rectangular plate ABCD of width W and height H subjected to a single force F applied at C at an angle theta. This system is clearly not equilibrated because the resultant force is not equal to zero. So my objective is to understand how to equilibrate the plate by applying forces at various corners, and I will consider two scenarios. First, I will see if I can do it by applying a single force at one of the corners, or I will also consider possibilities for applying more than one force at more than one corner. Let me begin the first case when I would like to equilibrate the force F by applying a single force at the corner A. It is clear that the force equilibrium requires me to apply the force F that is opposite to the force applied at C. By doing so, I have satisfied force equilibrium equations simply because sum of the forces acting on the plate is equal to zero. However, I can see that the forces F and F form a couple. These are two parallel forces opposite to each other, and they're separated by some distance. Therefore, as shown, the system is not self-equilibrated. To understand how to self-equilibrate the system by applying additional forces, let me do the first exercise and compute the value of the coupling. To do this, I will replace each force by its horizontal and vertical components, so that in total I have now four forces. Since the moment of a couple is independent of the location of the point with respect to which I evaluate the couple, I can take the point A, and this gives me the following equation. Sum of the moments about A involves the moment due to the force F sub x, whose arm is H, and the moment of the force F sub y, whose arm is W. Both moments are counterclockwise and therefore positive, and this gives me the following relationship. I would like you to think about what is the physical meaning of this term in parentheses. Think about what are its units and what it should represent as far as the couple goes. Next, let me consider how to equilibrate the couple by two vertical forces. The forces I apply at B and D, the forces are called G, and these forces are such that they also form a couple. Naturally, this couple is acting clockwise because the original couple, marked in red, acts counterclockwise. To balance the original couple, the couple formed by the forces G is on one hand equal to GW, because W is the distance between the forces G. On the other hand, its magnitude has to be equal to the magnitude of the original couple, which gives us an expression for the force G. this is not the only way of balancing the plate. I can also balance the plate by looking at the horizontal forces. Again, these forces are called G. They form a couple, and the only difference between this case and the previous case is that the couple involves a new distance h between the G forces. The rest is pretty much the same, and this gives us the answer. Thank you.